Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the intersection of quadratic curves. This is part 11, and I encourage you to check out all the other parts prior to this video, all on Numbers Simplified. And make sure to subscribe so that you don't miss out on any of our future uploads. We are still uploading other videos in this quadratic list series and also on other topics that might be of interest to you. Recall from the discriminant video, quadratics part 10, the discriminant of a quadratic given as ax squared plus bx plus c, where the a, b, c are elements of real numbers and a is not equal to 0. The discriminant is given by capital letter D is equal to b squared minus 4ac. And with that, there were 3 cases. Now those 3 cases are cases that we are going to look at once again. 1. Where the discriminant is greater than 0, we would have 2 distinct intersection points. 2. Where the discriminant is equal to 0, then we have 1 intersection point or just a tangent. 3. Where the discriminant is less than 0, this implies that we don't have any point of intersection. Case 1. Where the discriminant is greater than 0, this would imply that we have 2 distinct real roots or 2 intersection points. Where we have a greater than 0, then it implies that we have a minimum vertex, and for a is less than 0, we have a maximum vertex with 2 intersection points, as we can see, 1 there, 2 there for both graphs. Case 2. Where we have the discriminant being equal to 0, then it implies that we only have 1 point of intersection or a tangent. As we can see here, we've got tangents for both the maximum and the minimum vertex. 3. We have a case where the discriminant is less than 0, and with that it means that the vertex or the curve, the quadratic, makes no intersection with the line or any other curve. Let's look at example 1. A curve has equation y is equals to 5 minus 2x plus x squared, and a line has equation y is equals to 2x plus k, where k is a constant. Show that the x-coordinates of the points of intersection of the curve and the line are given by the equation x squared minus 4x plus 5 minus k is equals to 0. And b, for one value of k, the line intersects the curve at 2 distinct points, a and b, where the coordinates of a are minus 2, 13. Find the coordinates of b, c. For the case where the line is a tangent to the curve at a point c, find the value of k and the coordinates of c. The solution for a. So we equate y is equals to y, that's for the curve, which is the quadratic, as well as the line. So that we have 5 minus 2x plus x squared is equals to 2x plus k. Moving the 2x plus k to the left-hand side, we would have that. And of course, grouping the like terms, we would have x squared minus 4x plus 5 minus k is equal to 0. And labeling that equation star for ease of reference. So that is shown. Moving on to b. At the point a, minus 2 and 13 as the coordinates, from the linear equation we are going to get 13 is equals to 2 times minus 2 plus k, implying that k is equals to 17. Then substituting for k into equation star, we have x squared minus 4x plus 5 minus 17 is equals to 0. So that implies that x squared minus 4x minus 12 is equals to 0. Then using the factorization method, we can factorize in this particular manner up until we get x plus 2 times x minus 6 is equals to 0, implying that x is equals to minus 2 or x is equals to 6. Since x is equal to minus 2 is an a coordinate, we consider x is equals to 6, and substituting it into the linear equation, we have that, implying that the point B is 629. We move on to solution C. Where the line is a tangent, then the discriminant is equals to 0. So we take that equation we had, equation star, taking the b, the a, and the c terms, we are going to get that, so that we get to 4k is equals to 4, implying that our k is equals to 1. Substituting for k into that equation star, we are going to get x squared minus 4x plus 4 is equals to 0. Now solving for x using the quadratic formula this time around, we are going to substitute for the a, b, and the c. We are going to have x is equals to 2. So substituting it into the linear equation, we get the y of 5. This therefore implies that C is the point 2, 5. Example 2. Find the set of values of m for which the line y is equal to mx plus 5 does not meet the curve y is equals to x squared minus x plus 6. The solution. We equate y is equals to y, implying that x squared minus x plus 6 is equal to mx plus 5. So grouping the like terms, we end up having x squared plus minus 1 minus mx plus 1 is equals to 0. So the discriminant over here, selecting the a, the b, the c's, is going to be 1 minus m squared minus 4 times 1 is less than 0, since there is no point of intersection here. So what we have then, solving for this inequality that was formulated, we are going to have minus 1 minus m squared minus 4 is equals to 0. Recall from our quadratic inequalities videos, and I encourage you to check it out if you haven't, so that you don't miss out on some crucial steps here. So we equate this to 0 because we're gonna deal with the inequality later on. So solving for m, we are going to get m is equals to minus 1 plus or minus 2, implying that m would be either minus 3 or positive 1. Right, so from here we can see that our a for the inequality that we have is a value that is positive. So it means that the vertex would be a minimum point. And for values that are in between minus 3 and positive 1, the curve has negative values, and otherwise we have positive values. So with that, and looking at the inequality that we have here of less than 0, it means we are interested in the values in which the curve has values that are less than 0 for y. So our final answer becomes from minus 3 to 1. That is, m is less than 1 and greater than minus 3. If you've made it thus far into the video, I say congratulations. I leave you with a task. The line y is equals to mx plus c is a tangent to the curve y is equals to x squared minus 4x plus 4. Prove that m squared plus 8m plus 4c is equal to 0. Remember, your experience in our sessions, your preferred future topics, your questions, concerns, and suggestions are always welcome here. Make sure you type them in the comments section. Subscribe so that you don't miss out on any of our future uploads on this quadratics list or on any other topics that might be of interest to you. Thanks so much for watching Numbers Simplified. God loves you.